Alright, today we're going to be learning about atomic structure. Atomic structure is the most important topic that you're going to be learning about in chemistry because it underpins everything else. There is no aspect of chemistry that will not be involved in atomic structure. If you're in foundation, you can get quite a lot by just putting in the numbers and it works out on the calculator. But in a higher tier paper, you will not get anywhere unless you are following the rules exactly. Okay. If you look at your periodic table, you will notice that there are always two numbers. The first number being at the top, and that's referred to as the mass number. And then there is the number at the bottom. That is referred to as the atomic, and then in brackets it says proton number. Now, as a rule of thumb, we're going to be using the bottom one first, and then we'll use the top one. If you ever are confused which one is which, if you look at the top of your periodic tables, it has it in a key. So you should never forget this. Okay, first number I'm going to look at is this 2. So for helium, we have 2 for the atomic or proton number. That means I have 1, 2 protons. Now protons are my first subatomic particle. And I can always remember the charge on a proton with my very simple rule of PP. Protons are positive. That means they have a +1 charge. So, protons are positive with their +1 charge. I have an atomic number of 2, which means I have 2 of them in my nucleus. Which brings me very quickly on to my next number, my mass number. Now the mass number is actually the mass of the nucleus. Now if I have 2 protons in my nucleus, and then it's 4, I need another 2 particles in there. And those 2 particles are neutrons. They're very easy to name because neutrons are neutral. Very simple rule here, neut, neut. Which means they have a neutral charge, so charge 0. Now the last thing that comes up doesn't really follow this, but we can use it to find out. If I have 2 positive charges in this nucleus, I need to have 2 negative charges to look out for it. So what we have are 2 electrons that are around in the shells. So for the most part, these electrons are the same as the protons in a neutral atom, but this does change later and we'll talk about that at another time. Okay, one of the helpful ways to remember this is both negative and electrons have 2 E's in them. So we have our 3 rules. Neut, neut, PP, EE. I will put the extra 2 bits in so that we can zoom in at the end. We have the shells or energy levels. They do use them interchangeably. And we have our nucleus, which is made up of our protons and neutrons. Okay. Press play. Oh, so we're going to just try this with one new example. So if I have fluorine, and we'll be able to find fluorine in group 7, that's to the right of the periodic table. If I look at it, and I circle the exact same things, I have 9 for my atomic number. So that means that in my fluorine atom, I have 9 protons in my nucleus. I have 19 for my mass number. If I have 19 for my mass number, that means there is 19 in my nucleus and 9 of them are protons. That means that I have 19 minus 9 protons, which equals 10 neutrons. Now, because this is a stable atom, it has a neutral charge, I need to have 9 electrons to balance out my positive proton charge. Cool.